computer. So these are updates. Now I'm doing AI updates every week because there are so many things coming. And this week I was unfortunately very busy with some unrelated stuff. So here are some updates. How many entries in Hugging Face? I don't know. Gosh, it's more than 1300 for sure. Maybe 1400 or something. It was 346 entries in July 16th, and after that it started growing. And the reason why it started growing, because on July 18th, Meta introduced their Llama version 2, open source, even for businesses, and this is like a nuclear blast. And what's happening, a lot of development, and this blast wave is going out, and people don't know that it will hit them, but the blast already happened, so it's inevitable. Okay, Alama model, we spoke about it. I think I demonstrated how to use it on your local computer. There is another called GPT for all.io. Well, Falcon model was released. So these are from Arabic countries. They had a Falcon 40B, which was on the first place before Llama model. But there is new Falcon, which is trained on 3.5 trillion tokens. It's a huge model. It's like ChatGPT, basically. It requires big computer. But its parameters, although it's good, but its parameters, its results, its accuracy it's not a champion. We will see. Now, Claude, Anthropic, and it's a company who make Claude Chat. So they introduced Claude Pro, and what it is like ChatGPT. You can pay $20 a month, and you will get more features faster. You can get more requests and whatever. So it's a good thing if you're a heavy user of Claude. Of course, Claude Pro is a good thing for you. Well, it turned out that Apple spends millions of dollars per day on training LLM, so they are really, really serious about getting into this game, especially conversational assistants. Microsoft OpenAI Enterprise Service pricing. I still don't know the pricing. Microsoft filed a patent for AI backpack. I mean, they file many patents, but I think it's just curious that you can wear a backpack which has some AI in it, powerful enough to help you in your life. Google recently made a lot of updates, so TPU4 available to public, Do It AI, which is assistance for developers, digital watermarking of images, Google, NVIDIA, and Spark. Well, Google Meet now added AI functionality to this application. You know, Google Meet is like a video conferencing. Okay, open LLM leaderboard. So I was not able to get all the information. I downloaded only top portion, but what we have. So first of all, a lot of entries, right? So Llama was open sourced on July 18th. Please remember this date. I mean, I think it's really historical. July 19th is the day of Bastille, right, in France, right, when it was attacked and whatever. And so open community creates new data sets, new training protocols to improve the models, and suddenly we have this tremendous growth. And also they work on reducing the model size, and also they remove all safety, so they make it uncensored. And this is like a really, really interesting development, right? So new models, the winners are mostly variations of Meta's Llama. All top positions are 70 billion parameters, 16-bit, and require a relatively big computer to run the whole thing. But you can reduce it to number of parameters, and you can reduce a number of bits from 16 bits, which is 2 bytes, to only 4 bits. And surprisingly, you don't lose accuracy. So let's look at what we have here. So on the first place, we have this model, which is again variation of Llama. It is 16 bits. So it requires a lot of memory to run. And by the way, it's easy to calculate. So you have 70 billion parameters, and each parameter is 2 bytes. So it's 140 gigabytes to just put it in memory, and then you need maybe another 20 gigabytes because there is some other stuff, not just weights. So about 160 is a good estimate. Here's another one, and this is 8 bits. And why I put 160, I'm not sure, but because it's only 8 bits, so it requires less memory. And then here you have 4 bits, you see, on 50, and look at average accuracy. It's 70, and the win is 73. So it's not that far, but it's 4 bits. And what it means is that if you buy a MacBook, not a MacBook, yeah, MacBook Max with M2 chip and 64 gigabyte of memory, at current price, you can buy it at like 2.5 thousand. Like it's really not expensive at B&H, for example. So yeah, 45 gigabytes, and the computer has 64 gigabytes. So yeah, you can run it on a Mac laptop. That's amazing, and the accuracy is about the same as the top of the list. So here we have another model, which is original um, Llama 65. This is the first Llama. This is not the second one. Okay, and this is this new model, 100 billion parameters, which I told you about, and it's on place 61. And it's you see, it's losing like 5 points to the winner. And even 4-bit model is better than this huge monster. So this huge monster requires 400 gigabytes of memory to run, but you can use a better model on a laptop. Okay. Then there are some other models, like here we have original Llama 2 as released on July 18th, right? And then we have this model, oh, this is 13 billion parameters. So when you decrease number of parameters, usually you have strong degradation in the quality. So this one is on place 122. Now these locations are approximate below because I couldn't get there because I didn't learn how to download the whole list. But 4 days ago, these were positions. So this is 30 billion parameters 4-bit, 40 billion 16. This is original Falcon, which was the leader two months ago. 13 4-bit, 7-bit. So 7 billion parameters are really far away, and the quality you can see. So this would be the model you download on your laptop, and the quality is much worse than the champions. What else here? Yeah, that's it. So this is about memory and price. I was trying to figure out what computer you can buy to run these models at home. So at first, 70 billion 2 bytes, which is the original Llama 2, it requires 140 gigabytes, so it is expensive, right? There is a company, TinyBox, which now you can deposit $100 and eventually receive computer called TinyBox for $15,000, and it will be able to run this model and be pretty like fast doing that. Then there is a 1 byte parameter, so you need 80 gigabyte of memory. Then you have 4-bit, and this you can already run on 2 video cards, or you can run on 64 gigabytes Mac. This you can run on just one NVIDIA video card, 3090, and the rest you can run on like no, this is again, oh, these are all the models 4-bit, but different sizes. But again, you can run them on laptop. So there are technically several solutions. You can buy a desktop with one NVIDIA card, and then, but then you cannot run the 70 billion parameter model, right? You can get this MacBook Pro 14 or 16 with 64 gig memory and use that. You can build your own computer with couple identical NVIDIA RTX 3090, connect them with this connector. It's called NVLink. It's like $80 on Best Buy. It will require a lot of power, so you need maybe 2 kilowatts power supply. And there are multiple links. People are doing this and exchanging their experience. Okay, so this is description of the TinyBox by George Holtz. And well, if you want to spend $15,000, I don't know. Um, Rust. So there is a model running in Rust. In Rust, Rust is a very fast performing language, good. And there is another project called XLlama. So it's a Python, C++, and CUDA, and it's kind of like Ollama. So it can run again small models, 4-bit variations of them, and so you can go to this GitHub. I will upload all this with all the links as usual, so you can then explore them yourself. Now, how do open source LLMs compare to GPT-4? So here I took the winner of the open, so that's what I was talking. So this winner, right? And it is here. And this is the top 40-bit, which happened to be a 13 billion parameter model. Look at GPT-4. So ARC, which is reasoning, this is AI to reasoning challenge, 25 short, a set of grade school science questions, right? This is ARC. So this is 96% for ChatGPT. This is human level. It's not just human, it's a good, smart human. The next is HelloSwag, 10 short, a test of common sense inference, which is easy for humans but challenging for models. Again, very good results. And by the way, compare ChatGPT 4, 96, GPT 3.5, 85, and the top winner, like Llama variation, is 72. So it's a big difference. And 4-bit is really stupid in comparison to this. So if you want model to be smart and understand complex questions, you have right now you have no choice. You have to go to ChatGPT or to Claude or something like that. HelloSwag, MMLU, this is different sciences. So it's a test, MMLU, a test to measure text model, multitask accuracy, 57 different tasks, including elementary mathematics, US history, computer science, law, and so on. And again, you see ChatGPT is head and shoulders above, right? It's much better than previous three. So this is paid model, right? And this is free. And well, this is Llama variation, and this is 4-bit Llama. And again, truthfulness. So how much you can trust the model? Well, you cannot trust any of them. So they all can hallucinate, or they all can give you the most common answer, which not necessarily the right answer. So this is like good to know this comparison. Training requires more hardware than inference. Yes. When you're doing inference, maybe running just one query at a time, it's easy for computer, but training has to go through a lot of data over and over and over and over again. It's a very intensive task. Okay. I tried to compare different video cards and different ways to run the models. It's very difficult because different providers cite different metrics and you don't know how to compare them. But you can use a graph where you can actually run the same thing through different hardware and you can compare. So here, for example, H100, which is fastest video card from NVIDIA, and you see its performance, it's quite high. And here, for example, we have NVIDIA RTX 3090, and it's of course much slower. This is old V100 model. So this is H, where is A100? So here is A100. So it's about here. Okay, the tiny box, which I mentioned, $15,000 computer, it looks like it will be using 6 AMD 7900s XTXs. Each one of them is 24 gigabyte of memory, so six of them is 144 gigabytes. And well, why they're selected? Because, well, you can compare them with NVIDIA GeForce RTX 4090. 4090 is faster but more expensive, and it's more expensive for like float operations per second. So this AMD Radeon may be a better solution if you want to build your own computer. But of course, for that, you need to port all the, not the CUDA libraries, but you have code which runs on CUDA, and you need to have some way to convert it to running on AMD. And this is done, this is available now. Okay, I really like this article by Jacob Marks. And what he describes is that he was working as a team. They're working on prompt engineering, and they learned a lot of lessons. So one of the lesson is that every time when you receive a response from LLM, you have to do painful post-processing. So it's inevitable. You need to use regular expressions, remove hallucinations, and so on. And second big thing is that you should not ask LLM to do one task, uh, one big task. You have it's better to ask a series of simple questions. So if you structure as a chain, like that's why a length chain, or as a chain or a tree, and of more simple questions, you'll get better results, better reliability, and it's easier to maintain as a kind of production grade. Uh, and here I just reproduce some numbers and results from ChatGPT and from top 4-bit model, so to see how ChatGPT is much better. So ChatGPT, maybe you can ask a question and get a correct answer, but with a stupid model, you cannot expect correct answer. But if you split it in a series of simple model, simple questions, which the 4-bit can answer, then you can make a smart system from stupid models. And this I will talk about it a little bit more. So George Hotz is a hooligan. It's like he's a hacker. He is known for jailbreaking the iPhone and PlayStation and stuff. And this is a company. He runs tinygrad.org to create the computer tinybox to run LLMs. There is a very good interview here on top. You see YouTube interview. It's like 3 hour long. I really, really like this interview, and these are some takeaways from these interviews. Uh, so he advocates open source as essential for the safety of AI systems. Um, yeah, so he was saying that if you have one central organization which claims to create safe model, but then it's like in Terminator movie, like they can make a mistake or whatever, and he believes this is a recipe for disaster. But then when everybody has access to AI, he believes that most of the people are good, and then they will try to fight for good and to conquer evil. But then, of course, you can say, well, if you have an evil person who is stupid and cannot do like much harm, but when he armed with AI, suddenly he can become very, very dangerous, and something may happen so fast that good people will not be able to stop him. So yeah, there is no one answer to all these questions, but this is a really, really interesting conversation. He's a very original person, very knowledgeable, very originally thinking. So I recommend. Now, this contextualai.com, this is a company which raised 20 million in June, and I like what they do. And what they do, they concentrate on making private solutions so that you can use LLM locally and that you don't have to send your data to the cloud. They're specialists in all these things like foundational models, the dense retrieval, evaluation, multimodality, representation learning, and so on. And they're solving challenges like how you fight hallucinations, how you figure out why LLMs say what it say, how you make sure that your model is compliant, because one of the risks is that the model can retain some data which is private, right? And how you customize them, how when you get new data, model learns this new data, how you maintain privacy and so on. And what they say is this journey is only 1% finished. So we're at the beginning of this journey. And yeah, for me as a data scientist and programmer, this is very exciting because that's approximately what I want to do. Uh, running Llama on Mac Silicon. So Mac computers, my favorites. And here you can see Mac Studio, different tests. This is Ultra, this is M1 Ultra. M2 is a more recent model. We're expecting M3 in a couple months, but so now it's M2. This is MacBook M2 Max, and this is RTX 4090. So you see that NVIDIA video card is much faster, right? And you also see that Ultra is pretty good. I mean, uh, Well, it's your choice whether you build your own computer and spend a lot of money, and you cannot find already pre-built computer. I mean, you can, but they will be expensive. They will be like tens of thousands of dollars. And Mac, like with 192 like gigabytes, you can buy for $5,500. So this is peanuts in comparison to more expensive systems. And you don't have to build anything; you just buy it in the store. So I love Macs. How Llama CPP is even possible. So people sometimes, so there is a project called Llama CPP on GitHub, and so there is a post which describes why it's fast. So look at this comparison. So you have 800 video card GPU, which was used to train ChatGPT, and you have MacBook with the M2 chip, right? And there is two parameters, memory bandwidth and operations per second. So let's look at, for example, at MacBook. On MacBook M2 chip, GPU, CPU, and memory are on the same chip, right? But still, when you're moving from memory into the compute, this is the speed. Well, it actually depends on the model. On the regular M2, it's 100 gigabytes per second, but on Pro it's 200, on Max it's 400, and Ultra is 800. So it depends how much money you spend. But let's say you have 100, and on A100 you have about 20 times more speed. But then consider operations per second. Wow, right? So this is like 200 times more. 800 is capable than MacBook. But the limiting factor is actually memory bandwidth, because compute is very fast and mostly the compute just waiting to receive the data. So when you're running just one thread, like one question, so batch size is one, then the limitation is memory bandwidth, and MacBook will be about 20 times slower than A100. But when you're doing the training, when you're running batch sizes of like 160 in parallel, right? When you're serving inference to multiple users at the same time, then of course a powerful system with a lot of A100s or H100s will be much faster, like 200 times faster than your MacBook. But then of course the system will cost $500,000. So that's what Azure OpenAI use. Okay, building reliable systems and smart systems. So how to make a reliable system from bunch of unreliable blocks? How to make a smart model out of bunch of stupid models? Well, reliability you can achieve using redundancy, several elements in parallel, and average the outputs. Smart, you can make something smart from stupid blocks if you split complicated task in like small pieces, which stupid model can answer. So you're using chains and trees. And this is, by the way, similar example between bagging and boosting. Like this is in standard classical machine learning. So you have bagging where you have multiple, well, let's say trees in parallel, or computers, and they calculate something, come to a conclusion, and then you democratically vote to decide on like a decision, right? And this is how it is done, for example, in spaceships, how you achieve, like if one of the computers dies, the other two still work and still will provide the answer, right? So this is redundancy, democracy, whatever you can think. This is how Congress works, so this is how Senate works, whatever. And this is boosting, and boosting, this is how science works. So you start with the first approximation, and then you correct. This is also how open source development works. And this is the way to make things incrementally better, smarter, more correct, right? So this kind of approach. Okay, this is the end of the presentation, and let me stop the recording.